So today we're going to learn about the importance and use of water. This is for the OCR A-level spec. It's for section 1.A and it's that top bullet point looking at the importance of water in supporting life on the planet. So Earth is one of those lucky places that has liquid water, unlike some of the other places in our solar system. This enables it to support life, and there are many different ways in which it does that. One of the key elements is that it actually affects the thermal conditions. So here's a picture of the ocean, which covers 70% of the Earth's surface. And solar radiation will hit the ocean, and what the oceans can do is they can absorb the heat. They can absorb that solar radiation, and they will store some of that heat and slowly release it. That is one way in which they redistribute heat. Another way is the fact is this water will eventually evaporate and turn into clouds formed from water droplets and water vapor, but also around ice crystals. And they also have an effect on the thermal conditions. Some solar radiation will actually be reflected away by the clouds. It's something that we call the albedo effect, which is how reflective a surface is. So clouds reflect this solar radiation, and this actually lowers the surface temperature. So it kind of moderates the heat on Earth, and nearly a fifth of all solar radiation is actually done in this way, reflected in this way. So these are two ways in which the thermal conditions of Earth are moderated by the water on Earth. Another way in which the water on Earth has an effect on the conditions is that water vapor, obviously this is where liquid water evaporates and turns into vapor. It's a really, really important greenhouse gas, along with those other gases like CO2. And what that does in terms of the temperature of the Earth is when solar radiation comes in, it's reflected as infrared radiation, which is long wave radiation. And what the water vapor does is actually absorbs that infrared radiation and radiates it out again. So when it absorbs it and radiates it out again, this actually warms up the atmosphere. So all it's doing is it's kind of, basic terms, you say it was trapping that kind of radiation from leaving, and this naturally radiates up the atmosphere, and therefore if we didn't have it, conditions would be about 15 to 20 degrees lower than they actually are. So it actually helps maintain and sustain life by providing warmth for the atmosphere. Obviously, if we put too much water vapor or any other greenhouse gases, that's where we get the enhanced greenhouse effect, and that's where we get the conditions leading to extended and enhanced climate change. So we've seen how water can help create the conditions on Earth for life, and now we need to know how the water is actually used by humans, by fauna, so that's the animals, and flora by plants. So starting with flora, one of the most obvious ways that plants use water is for photosynthesis, so to make their food by combining it with CO2 and sunlight. And then they will use the glucose that they've created through photosynthesis when they respire, and that actually releases more water. So water is really important in those key processes happening inside a plant. We also need water to make sure plants stay rigid and that they can transport nutrients through a plant, and they're even used to help cool the plant down through transpiration. So when transpiration occurs and water evaporates from leaves, that actually cools down the plants, which is the cooling process is really important, not just for plants, but for humans. So humans sweat, and that actually cools down. So when we drink water, part of why we're drinking water, so we can use it to sweat. Alongside cooling down, water is really, really important for both plants and for animals in terms of all the chemical reactions going on. So if you're transporting nutrients again around the body, or if you're transporting oxygen, you need water in your body to be able to do that. So pretty much all the things that are going on inside your body or in an animal's body are being fueled and being caused by interactions with water. As we said about sweating and transpiration for plants, it's the same for animals. They evaporate water through their kind of when they pant. Not all animals, but these are talking about animals that are normally fur covered, so like dogs, birds and certain types of reptiles. They all pant, and that water evaporating off their mouth in the panting process is actually how they get cooled down. The last thing we really need to consider in terms of humans is the fact is that most of the economic activity that we do on Earth involves some sort of water. So this is everything from farming, where we use it for irrigation, in the creation of hydroelectric power through dams, which create electricity. Manufacturing uses an incredible amount of water, but then even stuff like just supplying the drinking water for society, making our sewage systems work, and also leisure activities. So we build a reservoir, we generate electricity off of the back of that using a dam, but then we also use that for sailing and water skiing and other such activities. Now we know how important water is on Earth, we need to look at it from a systems approach. So water on Earth is a finite resource. That means we don't lose or gain any. And because of this, if we look at it on a global scale, this means it's a closed system. A bit like having a pan of water and having a lid on top of it. The only thing that could actually enter the system is energy, and the energy for the global system, the hydrological system, comes from the sun. So that's the only thing that can cross the boundary, and that's the engine that drives all of the processes here in the water cycle. As I said before, no water is lost or gained when we look at it at a global scale, so you don't get water drifting off into space. However, if we change the scale, and here I've got an example of the Amazon rainforest. This is a drainage basin. So even though it's a very large drainage basin, it's a drainage basin. And there would be many, many drainage basins in South America, depending on the amount of rivers. If I look at this on a smaller scale, we can see this is an open system. So a bit like using the pan metaphor, it's a bit like having a pan with no lid on it. So other things can come from outside of that system into the system. And so we can not only get energy, like the sun transferring its energy across the boundaries of the system, but also matter, and in this case, water. So how does that work in this example? Well, energy from the sun would have heated up the Atlantic Ocean. Remember, that is outside of this drainage basin system. But that heats up the ocean, which turns into clouds, and then we get the water inputting into this drainage basin system as rain. So the rain enters the drainage basin system because it's travelled from somewhere and ended here. We could then get this water actually leaving here because, like I said, it's an open system, so things can be inputted, but they can also be outputted of here. So water might flow out through flow or groundwater flow or through rivers out of the drainage into outputs. We wouldn't get this in a closed system. If it was a closed system, all the water would be kept in the system, none would be able to come in and none would be able to come out.